This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV. This Week in Virology, episode 1251, recorded on September 5th, 2025. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today from Ann Arbor, Michigan, Kathy Spindler.
Hi, everybody. Here it's 70 degrees Fahrenheit. We've had the best stretch of beautiful weather, and it continues. A blue sky, and that's 21 Celsius. We did escape the effects of the solar storm, meaning that we saw no auroras, even though it was advertised that it might be really good, and I went out and looked. Oh, well.
We are now getting warmer again. So we had fake fall. Now we're getting into fake summer. We only have one day of fall, actually, because it gets hot now for a long time, and then suddenly one day of fall, and that's it. It's 28 C here in Chelsea. Also joining us from Montreal, Canada, Angela Mingarelli.
Hey, everyone. Here it is 73 C, so basically like Kathy. I think that's 23. Sorry, not 73 C. Wow. Can you imagine? 73 F. It's 23 C. And here it's nice during the day, but it is getting cold at night. Like at night we go into like the 50s, I think like 11, 12, 13 degrees,
Yep.
Which September as usual is. You have to dress like an onion. You're like freezing in the morning and then sweating in the afternoon. But I'm actually looking forward to the winter. I know that sounds crazy, but I have a fireplace now and I want to use it. So.
Okay. Also joining us from Western Massachusetts, Alan Dove.
Good to be here. I have a fireplace in the background that I basically never use. We used it like right after we moved in and then never again. Anyway, certainly not today where it's 80 Fahrenheit, 27 C, humidity's 60%, and it's kind of a little bit of rain, a little sticky outside. But the cold front's supposed to blow through and then things are supposed to get lovely next week. Looking forward to it.
And from Austin, Texas, Rich Condit.
Hi, everybody. 97 Fahrenheit, clear blue skies. Tomorrow, it's the high is supposed to be 88, and the following day, 85. So we're going to get a little break. Then we're going to go back up to mid-90s. You know, you got to hang in there until late October around here.
Hold on a sec.
That's way too hot for me. 97, you said? That's like 37? No, thank you. Even.
Oh, yeah.
Yeah.
Yeah, it's hot.
That's an incubator. Yeah.
Yeah, it's hot.
Well,
So you get out in the morning.
We have people in on the live stream from Phoenix, and it's typically over 100, and Sacramento, California, where it's typically over 100. So that's amazing. If you like these programs where we give you the weather, whether you like it or not, I know a lot of people don't like it. But
Tough.
It's just too bad, we like it. You could fast forward through it, right?
Yep.
Modern technology.
Modern technology and Jolene Ramsey's doing timestamps. So
Yeah.
That's right. You can get right past it. We'd love your support. We'd give you science on these programs, right? That's the whole point. They teach you science, and we give you the real science, no lies, no disinformation, which is very common today if you don't be careful about what you're talking about. And so we'd love your support because we don't do ads on these programs. Go to microbe.tv/contribute. There are a number of ways you can help us. We'd appreciate it a lot. By the way, we just had Dan Wilson on Office Hours this past week. That's our live stream. Dan Wilson, of course, is from Debunk the Funk.
He's good. I really enjoy Dan.
Yeah. Okay. A couple of news items. And, I understand that people don't want us to be political, but what happens when politicians make vaccine regulations? I mean, they're not supposed to do that because they're not public health people.
Yep.
So, for example, the Florida Surgeon General and governor have decided to end vaccine mandates, especially for kids going to school. And I understand that this is a highly political thing aimed at getting votes, right? But it affects, thank you very much, it affects people's health. And so we can't do that anymore.
And remember,
Is
they
this
can't
including-
vote for you
Sorry.
if they're dead.
Is this all vaccine mandates, Vincent? Like
Yeah,
MMR, everything.
Well, mandates for kids.
Apparently,
So for children, what were they to begin
But for
with?
kids, to get into school, you needed to have certain.
It was
vaccines,
MMR
right?
though, mainly, no?
Well, there's
oh no,
polio vaccine.
there's a whole
Oh, and
bunch.
polio
No
also
bunch.
true, of course. There's multiple. So
There's
now
a-
there's no
there's a
mandate,
whole
so no
bunch.
child.
Yeah, and I believe diphtheria, pertussis, tetanus, the whole childhood series is required in most school systems.
I think Rich brought children up in Florida. He might know.
I did, but I can't tell you. But
that was
I
a
can't
while
tell
ago,
you,
though.
I can't tell you. Actually, they by the time they got to Florida, they all were vaxxed up. They
But
were
it's
in,
all like the typical
Buffalo
things that.
before.
Okay.
Yeah.
There's I can't give you the detail because I forget, but it is detailed somewhere. Some of these, in order to unmandate them, requires legislative action. Okay? So some of them are actually legislated mandates. Some of them are not. And as I looked at the list of vaccines, I didn't see any particular logic to what was and what wasn't. But so some of them can be just lifted by effectively executive action. And some are going to require the legislature. It will be interesting to see what the legislature does with this.
Well, it says here that the Florida plan to end vaccine mandate will face challenges in the state legislature.
Yeah, right. I think some of them can be lifted, but some of them, they require the legislature.
Well, that would be good because perhaps, logical heads will prevail.
We'll see.
We'll see.
Yeah. And
But-
it depending on how the state is set up, school districts may have the ability, counties may have the ability to do differently, but I'm not sure how this is all going to play out.
But just to be clear, folks, vaccine mandates for school entry are a good idea. All the states do it. They've been doing it for years. It's a great way to prevent infectious diseases, and there's no downside to it. The reasons given by the Surgeon General and the governor were ideological reasons. We don't want to tell you what to put in your body. Well, yeah, you're telling women what to do with their bodies.
Yeah, exactly.
already.
They only want to tell particular people particular things about what they can do with their
Yes.
bodies. Yeah.
So that's just nonsense. You really need to consider health, and that's what's at stake here, the health of children. And
Well, they're doing an experiment.
Yes.
Like a fast Google search, I see that MMR and polio need to be appealed, like legally, like in that they require legislative action. So it's only a few that don't actually need it, like
I think
vaccination.
the ones
Chickenpox.
that really disturb me are hepatitis B,
Yeah.
and I guess the papillomavirus vaccine is not mandated.
That's
No.
generally not mandated by schools.
But hepatitis B, I think one of the objections to that is that the first dose of that is given at birth.
that's right.
Okay. And people find that really objectionable. What? My newborn child, what you're going to do? You're going to stick them? Yeah, you're going to stick them.
Yeah.
Okay. Because that's how you eliminate hepatitis B from the population. That's absolutely critical. And
And of all of the bodily insults that are happening to a child that's just been
yeah.
born, that just doesn't even register.
that's trivial.
I hope that some parents will still vaccinate their kids, right? Even though the
Sure.
school doesn't say.
My guess is, and I saw another statistic about one of these polls about what people think about mandates. And in fact, there's I think it was over 80% of the population of Florida that supported mandates. So under those circumstances, lifting the mandates won't necessarily cause a catastrophe, though in the case of measles, man, you get down below 95% and you're asking for trouble.
I don't know. I think the straw will be if we have polio outbreaks, people are not
Yes.
going to
Yeah.
go for that, right?
Yeah.
Because we had one case in New York State couple of summers ago and went nuts. Everybody went nuts, right? So I don't think polio is, and none of these are acceptable, but polio is the poster child, right? So,
Literally, yes.
really, literally. All right, so, RFK has been trashing the CDC, as you know. We talk about it. He repopulated the ACIP, the Vaccine Advisory Panel of the CDC. He asked Dr. Susan Monterez to accept all of their recommendations. And she said, no, I'm not going, because they're anti-science, anti-vaccine people. And so she was fired as a consequence. But now some states have banded together to make their own recommendations. And so far, California, Oregon, and Washington have made a West Coast Health Alliance. And they say they're going to make their own recommendations because they don't trust the CDC any longer. And, I think there are a lot of good people still at CDC. The MMWR coming out seems to be still okay, but you don't know what they're eliminating and so forth. So maybe this is just the beginning of many states getting together and doing that. Now, many people now would like to get COVID vaccines, but apparently in some states you can't get them without a prescription due to the lack of guidance from CDC. The ACIP isn't meeting for a while, and they have to make recommendations for many states. So there are some states where you can't get it without a prescription, and some states where you can. Depends on the state. But,
and it also depends on which commercial, like if you go to a commercial pharmacy, if you go to CVS or Walgreens, they have to set corporate policy based on whether they think they're going to get sued. And so there are, a number of states where they've said, until things get clarified at the state level, we can't do this on walk-ins. And so states are now responding to this.
Yeah. So New York State Governor passed something to allow New Yorkers to get vaccinated, even at CVS. And apparently so has Massachusetts, right?
Yep, Massachusetts.
Colorado, too.
And Colorado.
So does that alleviate CVS from liability?
Yeah, it allows them to go back to basically what they were doing before, because the state says, yeah, you can do this, and then you can walk into CVS and get your vaccine. Now, I don't know about paying for it. That's going to be between CVS and your insurance company, and your insurance company is going to have their own thing going on. But the insurance company, from a financial perspective, they would like people to get vaccinated because then they're not going to cost as much with an emergency room visit.
Yeah, I was wondering about this.
Sure.
I was wondering how the insurance companies would react to all this, because it could
with horror. I mean, they're actually. I could say many, many bad things about health insurance companies and the way they're run, especially in the United States. But one good thing about them is that, to some extent, their interests are aligned with public health.
Okay.
They want people to stay healthy because it's expensive for them when they don't. And so preventive care is something that insurance companies are generally in favor of.
All right. Well, it'll be interesting to see how all this plays out.
Yes.
It sure will. And we are entering the respiratory virus season, so we'll see what happens. Because, as you will see in our snippet, things can affect outbreaks of viral disease. So let's use that as a segue. We have a snippet for you in Nature Communications, unraveling the role of viral interference in disrupting biennial RSV, respiratory syncytial virus epidemics in northern Stockholm. Stockholm is a city in Sweden. So this is the northern part of Stockholm. The authors are Kuli, Johan Hamrin, Anna Nilsson, Daniel Weinberger, and Virginia Pitzer from the Yale School of Public Health, the Karolinska University Hospital, and the Karolinska Institute.
I just want to point out that the Children's Hospital at the Karolinska is the Astrid Lindgren Children's Hospital, and Astrid Lindgren is the author of the Pippi Longstocking books.
Oh, how about that?
That's cool.
So, as you know, respiratory syncytial virus is a big public health concern. It's bad for young people and older adults and people with compromised situations. And in 2019, 100,000 deaths of children under 5 were attributed to RSV infections globally. It's a lot of kids.
Yeah.
As with many other viruses, it's seasonal, and it causes winter epidemics in temperate countries. Those are countries that have seasons like spring and summer and fall. And in northern Stockholm, RSV activity shows a biennial pattern, right? Every 2 years. Is that the right definition
Yes.
of biennial?
Yep.
I had to double
have-
check just in case.
Not to be, everybody
definition.
mixes up biennial and biannual.
I looked it
Yes.
up myself.
Biannual is twice
I
a
d-
year. Biennial is every other year.
I was like,
And to
this can't
avoid
be a
confusion,
spelling.
You could just say every 2 years or twice a year.
Yeah.
That's how some of the linguists would say to do it.
Yes.
Isn't it fun to use cool words, though, Kathy?
Oh, yeah.
Not if they're confusing. Not if 4 out of 5 people had to look it
Yeah.
up.
That's true.
Like in cellulo, right?
Right.
Oh, yeah.
get-
We'll talk
we'll get
about
to
that.
We'll get to that.
All right. So in northern Stockholm, sorry, go ahead.
By the way, throughout this paper, they're talking about northern Stockholm, and I never saw any clarification of why we're only looking at northern Stockholm. Like, I thought it was one city, but
It is one city.
My guess is I'm totally making this up, but they're using hospital data.
That was my headcanon too. Was just like
Yeah.
they had access to hospital data that
Yeah.
their catchment area is northern Stockholm.
Yeah.
All right. So RSV in northern Stockholm is biennial, or every 2 years, with early and large epidemics in odd-numbered seasons like 2001/2, and late and small epidemics in even-numbered systems. It's amazing. The viruses can be very fussy also.
Yes.
But there were changes to this pattern after the 2009 influenza pandemic. Totally changed what we were seeing in terms of the pattern that I just mentioned to you. So they had large epidemics in 2 consecutive seasons during 2009 and 2011. And then this biennial pattern shifted to early and large seasons in even numbered years following this pandemic season.
So it went
Right.
from big ones in odd numbered years to
Yes.
big ones in even numbered
Even-numbered
years.
And I
So this
just think-
provides conclusive evidence that the virus does not actually know the difference between even and odd numbers.
Yes, and it wants to mess with us also. So this gives you an opportunity to say what is responsible for these seasonality patterns, right? And so they had 3 hypotheses to explain this. First, a sudden increase in birth rates in 2009, which you will see there
Which was another item in the paper that I thought, why? But that's
Well,
never explained either. It's just an
people
observation.
staying home during the pandemic.
I
right?
guess I don't recall that being a big thing in 2008. But
I don't remember.
Reminds
I-
me of the blackout in New York City, right?
yes, right.
All right, number
Maybe
2, extremely
because it
low
was-
temperatures during
Well,
2009.
extremely low temperatures. The second
Extremely
one,
low
maybe that
temperatures,
was
but right. No,
the
the
birth
low
rate-
temperatures. Right. I thought of that too. Like everybody's staying indoors because of low
Inside.
temperatures, but the low temperatures were at the same time as the baby boom. So you'd have to go back,
the year before.
and
or
it doesn't.
whatever, yeah.
It's not obvious.
Who knows?
08 was also the financial crisis, so maybe a lot of people were out of work.
Well,
I'm
anyway,
not privy to northern.
the increased
Stockholm.
birth rate, the low temperatures were verifiable, as you will see. And
Yeah.
also, third hypothesis is the 2009 influenza pandemic itself. So maybe the virus interfered. So that's also verifiable. We know there was a pandemic in 2009. So what they do here is they have data on the occurrence of on all these 3 things, right? And they build mathematical models to try and understand what factors have the greatest influence on this alteration of season, right? And so they have from July 1998 to June 2018. So they have great records, right, in this country. Hospitalizations for RSV were seasonal, as we just said, and winter outbreaks in northern Stockholm, and this biennial pattern, right? And they have a lovely graph showing you the big and the small epidemics, right? So again, the big epidemics in odd-numbered years and the small epidemics in even-numbered years. And then as you move to 2009, 10, and 2010, you could see it shifts to even big and even number and small and odd-numbered years. So that's where those statements in the introduction come from. So they have this epidemiological pattern, which they can verify by all the data that they have. Okay, so now then they want to know why do we have this shift? And they did see, by analyzing the birth rate data in northern Stockholm, a 10% increase in the birth rate from 2010 to 2011. So what would that do? Well, it would increase the population
Susceptible
size
population.
of susceptible people, right? And that could affect the dynamics of the virus, right? And they also observed in climate records a exceptionally cold weather during the winters of 2010 and 2011, and they thought maybe this could affect the transmission of the virus. And then we have the H1N1 pandemic in 2009. I remember this pandemic because we were doing TWiV, and we didn't talk about it very much.
No.
And someone wrote in and said, hey, we want you to talk about it. So that's when we started covering outbreaks. Isn't that interesting?
Yeah.
Was it mostly in Europe, or was it also in North America?
No,
I don't
it
Oh, it was
was
definitely
global.
North America.
Yeah, we had it
Okay.
here.
It was
Oh, wait,
global.
is this the swine flu pandemic?
Yes.
Well, it had
Exactly.
probably originated
'Cause
in
everybody-
pigs. Yeah.
Everybody colloquially referred to it
Yeah,
as
referred
the
to it
as the swine flu
pandemic.
Pandemic
Yes,
of
yes.
2009. Yes.
Yeah.
Exactly. Okay, yes.
What I remember about that was most striking to me is how fast it circled the globe.
Yes.
It was weeks, as I recall.
Yep.
So they have records, of course, of the pandemic influenza virus isolations. They have the first peak in the week of September 14th. That's 2009, and the second in November 16th. And they also cite data in ferrets, which show that if you infect ferrets with influenza virus, it turns on innate immune responses that can, in fact, temporarily interfere with infection with RSV. But interesting, RSV does not interfere with influenza virus. So that's where they got this idea that maybe the virus was disrupting respiratory syncytial virus dynamics. So they make the meat of this paper, they make a variety of models to address these different factors. And so, for example, initially they use an age-stratified susceptible infectious susceptible model, a CIS model. It's a very common model used in epidemiology. They look to see whether the birth rate explains the biennial pattern change. So they use all the data that they have, they put it into these models. And
Angela, I want to correct something. You do have I actually agree now, because I forgot that the baby boom here is 2010 to 2011. It's not in 2009. So people going out less because of the pandemic would possibly fit that.
Possibly.
it's too cold. Yeah.
Yes.
Okay.
And because it's too, well, the too cold, seasonally too cold was 2010 to 2011.
But spoiler alert, Vincent's going to tell us that
Neither
What
of
did the
those
model
is the
show?
actual answer. Yes.
Birth rate and cold had nothing to do with it.
Yeah.
had nothing
Okay.
to do with it. Yeah.
That's it, folks. See you next time.
Yep.
But that's
So
cool.
this SIS model could reproduce the biennial pattern before it changed, but not altered. So birth rate is out. So then they also looked at temperatures using the same model. They look at temperatures and relative humidity. Again, it could account for changes. It could account for the seasonality before the pandemic, but not afterwards. So then they use the influenza data to put into these models, this particular model. And they made three scenarios. One, the interference are equivalent across the different periods. Two, the interference differ before and after the pandemic. And three, it differs across all three periods. And model one could reproduce the biennial pattern before the pandemic, but not after. And both models 2 and 3 could capture the dynamics of the observed dynamic change of RSV, and they accounted for the shifted pattern after the pandemic. And model 3 was the best. And then the rest of the paper is essentially using different models to do the same thing, just to make sure, because you don't want to put all your conclusions into one model. And they all agree that influenza virus was the factor that changed the seasonality of respiratory syncytial virus. They also look at different...
Sorry. The ferret data they had was to, as far as I remember, to support that the innate immune response, there was some sort of cross protection. It wasn't clear if it was antibodies, like humoral response, or if it was also cellularly mediated.
No, it's just interferon. Because it was a transient response, right? It didn't last. The antibodies would have been more durable, right? Yeah.
So they're suggesting it's something similar, right? And it's very fast within a few days, this like overlap.
Well, I think they say that's why they actually considered it, because of those data, right?
Yeah, and those data are from another group.
People, yeah.
This is strictly a modeling paper, but the two things line up very nicely, and the theory being that infection with the influenza virus causes this spike in innate immunity and interferon response that gives you about a 1-week protection window from RSV infection, and that's enough to slow down RSV at the population scale. And so flu is interfering with RSV.
Is it only interferon response? Like, have people show that it's strictly the interferon response and there's not other like players in the innate immune response?
They don't detail that. My guess
involved.
Is, your sort of go-to innate response thing is interferon, which covers a lot of bases too, right? Because interferon includes all the interferon-stimulated genes and all the different ways of turning on interferon in my mind. So it covers a lot of ground. But the details of what the interference is not going on, not elaborated on.
Yeah.
I have a couple of points and a lot of questions. The most important point I have is, or point and question is, why was the pandemic special? Okay, and I think one reason is that it was early.
Yes.
Right? So RSVs, usually hanging around going on a certain schedule. And if flu blows through and is gone and the interference is only going to last a week, then by the time RSV is ready, that's gone. So it can take off. That makes sense to me. I don't understand why there's a biennial pattern and why this should necessarily reset that. I don't understand why, if both of these happen at roughly the same time, that in a very regular fashion, there's more interference in alternate years than the other years. I keep looking at this figure too, which is fascinating, that shows the admissions due to flu or RSV on a weekly basis on the same graph, so that you can see the intensity and the timing of these. And you can see clearly that in the 2009 pandemic, they were skewed. They're not happening at the same time. You can see flu happens first, and then boom, where there was supposed to be is that supposed to be it's a large one. At any rate, you can see there's a big spike of RSV, but and that winds up resetting this pattern. But I don't understand why there's an alternating pattern.
Right.
I think it has to do with population immunity, right? You have to build up susceptibles, and so if you interfere with that because of influenza virus, then you basically delay a year, I guess, and that just shifts it.
The normal biennial pattern could just be a product of okay, you hit all the babies this year with RSV, and now RSV is shopping around for hosts the next
Right,
year,
okay.
and everybody's still, these
Okay.
babies are still immune, and there haven't been enough more born
Yeah.
naive.
I
And
mean,
then
do
the
we know-
following year is another boom year.
Do we know if that's true that like humoral responses decrease that fast? The titer
just
of
made that
RSV. Like no. I wonder if it is. I wonder if it is true though that it's like every 18 to 24 months ish. That there's like, I don't want to call breakthrough because whatever, but then
Right.
that you can now have an infection because the antibodies or whatever cellular response is now dampened because of like timing, like
I
a
don't
temporal
think it's
thing.
unreasonable but it is different for different viruses, right? So,
Mhm.
so the seasonality can be 2 years or 3 or 4 or 5 years. It really depends on the virus. And so I suspect it has to do with declining antibody levels. But I don't know.
I guess a question is also, is it that it's moving? I've always had this thought, but I've never actually looked into it, that it's moving across the globe somehow and that it makes it like literally like geographically the virus is in different places. I don't want to say the same virus, but I mean like that at one part of the year, it's affecting, let's say, the southern hemisphere, a specific part of the southern hemisphere versus like northern. Obviously, there are different circulating viruses, but there are some that are similar that are circulating across the globe. I wonder if it's people flying from one place to another, taking it there, then it kind of propagates there. And then I don't know enough about epidemiology to say. I'm sure epidemiologists are screaming into their cell phones when they hear this, but,
No, but
this is just a random
I'm picturing
thought.
this theory like people doing wave in a stadium. Right? So it
Yeah.
propagates maybe,
Exactly,
and then
just
it
like
takes
going-
it 2 years to propagate back to the same point, maybe.
So many
Could be,
winter viruses remain over the summer at very, very low levels. They're not zero.
Mhm.
So
Right.
those
Of
can
course.
all that they could reemerge as long as there's not another virus that's more fit than they are, right? And that's why often influenza viruses from the southern hemisphere, which have evolved to do different things, come to the northern and they're more fit and they outcompete whatever's there already. In some seasons they don't.
Okay,
So
so
it
it is
depends.
not totally crazy.
I don't think so. No, for
No.
flu, we
The
look
idea,
at
yeah.
the southern hemisphere during their
Mhm.
winter when it's summer for us.
Of
We look at
course.
what's circulating there and try and get an idea of
Yeah.
anticipating,
Mhm.
right? Yeah, for sure. No, it's okay. Travel makes a big difference, for sure.
So,
But then why
as-
wouldn't it be that every year we have all of these viruses, like the common cold, which we know is multiple viruses? If some of them were circulating earlier, like I'm not sure, is it known if RSV always circulates before influenza or vice versa? In other countries, not only in Stockholm, I mean like in North America, do we know who spikes first? And then if that affects hospitalizations, are there studies on that like in North America or in any other
I don't
place in
know.
the world?
Good question. Well, good
Actually-
questions.
Should be
actually,
true
if you look at
it's
this, if you look at this,
interferon.
if you look at this graph I was talking about, they spike at different times.
Mhm.
It only varies by a couple of weeks. But along this graph, it looks to me like they spike at different times, and not in a fashion that necessarily correlates with the biennial pattern.
Yeah.
Okay, so I don't get that. So, throughout this paper, I was thinking about Dixon because he's a medical ecologist, right?
Yes.
This is medical ecology on steroids. It's viruses influencing each other at a population level,
Yeah.
right? Which I'd never really, I guess I maybe had vaguely thought about,
Yeah.
especially on an individual level. Oh, if I get this virus, is that going to influence, is that going to, give me some resistance through innate immunity to some other dude that's coming down the road? But this is on a population level, and it's just cool. Something to really think about.
Yeah.
And it's
So
fascinating that this is a one-way street. Why doesn't
that's
RSV
interesting, yeah.
interfere with flu? Flu must have some, nah, you're not messing with me, genes.
Yeah, well, they do have interferon antagonists,
Yeah,
right? So-
right.
And of course, then there's SARS-CoV-2 interfering with other viruses as
Mhm.
well. But so they also looked at seasonal influenza viruses to see if there was any correlation there. And it's just the pandemic 2009 where they see this disruption of RSV patterns. So that's interesting because seasonal viruses, you have epidemics every year, right? So why don't they do it? It's a good question. I don't know. No, so then they want to know what's going on here. And we've already talked a little bit about that. Again, they use models that look at the change in the populations that you would get from a 10% increase in birth rate. And they say the temporary conversion of the susceptible to temporarily immune population delays the availability of susceptible individuals, and that delays the epidemic, basically. And that they say this also provides an explanation for the larger than expected RSV outbreak in 2010-11. They're more susceptible individuals because they didn't get infected previously, right, because of the pandemic influenza virus. So that's what they think is going on. So that's essentially the paper here. It's an interesting analysis, all by modeling pretty much, which suggests that the 2009 pandemic influenza virus interfered with RSV patterns and changed the seasonality.
And both of the papers we're talking about today are open access, so
Yeah.
people can go look at these cool figures.
But one point that's very important to remember, this interference, they say here, interference is less than a week.
Yeah.
And that's enough to
Yeah.
do this, right? That's amazing. So this whole system is very finely tuned, and that's nature for you, right?
Yep.
All right. And let's see. Even a temporary small disruption of the susceptible population caused by cross protection led to a change in RSV activity. And so why is this important? Well, it may help you deploy vaccination strategies, right? And see how, as they say, how vaccination coverage affects long-term disease pattern, leading to informed decision-making and public health interventions. This is what it's all about, folks, making informed public health decisions, not ignoring them, which is happening right now. Okay. So we have a paper which is in Science Advances. This is broad spectrum synthetic carbohydrate receptors, SCRs. Okay, remember that because they're going to say it a lot. Inhibit viral entry across multiple virus families. I would say inhibit entry, viral entry across members of multiple virus families. Okay, you can't inhibit a family.
That's true. They took like 2 or 3 pseudoviruses.
Yeah.
A lot of authors here. Oh my gosh. A lot of different institutions all over Cornell, NYU, NIH, Hunter, Spain.
I want to call out Hunter
places.
High School.
Look at that.
Wow.
Hunter High School.
There are 2 authors on here whose affiliation is Hunter High School. And I just, I'm thinking, when I was in high school, I was not doing anything near as productive as getting a publication in science. In Science Advances.
That's I know Hunter High School. It's on 94th Street. I used to walk by it every day on the way.
Apparently, it's a pretty good school if this is representative.
Yeah, it's very good. It's run by Hunter College, right? Which is further downtown, and it's one of these magnet high schools. Very good high school. I mentioned that to Stanley Plotkin.
I listened to that show. Yeah,
I was misthinking that
Bronx Science
was this, but it's not. Yeah, Netherlands, UCLA. Let's see. The first author. These authors contributed equally.
Yeah, so there are 2 co-first authors, Shahzad Ezzatpour and Kushabu Thakur. And this is a new one on me. 3 co-second authors.
Okay.
Buchholz, Choi, and Inbiaka. And then 2 corresponding authors, Adam Braunschweig and Hector Aguilar.
Aren't they 3 co-third authors? Because there's an author in between. No?
Well, no, so I'm counting the first
Kenneth?
2 authors as co-first authors.
Mm-hmm.
Then there's Ndede, who's the second author.
Exactly, and
Right.
3 co-third.
Oh, right. So then it's, 3 co-third authors.
Which is
Third
so...
author, that's right.
I've never seen 3 co-third. Co-second?
Co-third authors I had never seen before.
Co-third,
Yeah, co-second I had seen, which is a little odd, but co-third authors.
I don't know what the third.
I'm sure there were lots of discussions about this.
This is crazy. 2 co-first,
Anyway.
3 co-third.
Look, the idea here is that to be better prepared for the next pandemic. Vaccines are great, but they take a little bit of time to make, right? It took a year to make the SARS-CoV-2 vaccine, which is amazing, but it still took a year. And in that time, a lot of people die. So could we have broadly acting antivirals ready to go? And they would affect any one of many potential pandemic viruses, right? So this is the idea. And they say, oh, we have broad spectrum antibiotics for bacteria, but we don't really have small molecule broad spectrum antivirals. Now, small molecule is the key. You don't want to have antibodies or big proteins and small molecules that you have in stockpile, and then you can deploy them if something new emerges.
And the fundamental problem here, I mean, the reason we can come up with antibiotics is because bacteria are completely different from human cells. They have lots of structures that don't exist anywhere in our body, and we can chemically target those and develop antibiotics. Viruses are made of us. The virus makes itself out of the cells.
Us.
Viruses are us. And so their structures are built from our proteins and look a lot like our own body. And one of the big things in this paper is they're talking about how do you even find a motif that would be specific to a virus and then manage to target just it.
Now, the other challenge, of course, is resistance to antivirals, which, the antivirals we have now target viral proteins, typically enzymes like proteases or polymerases. There's some others, but in every case you get resistance, right? Because the genes encoding those proteins can change, and you can get resistance. And what they say here, something that really bothered me. They said something about high viral protein mutation rate. Oh my gosh!
Me too.
Yeah.
So then they say the other thing is, besides broad spectrum, and they use BSA, which is not good because that's bovine serum albumin. It's already taken.
I kept seeing that. Wait, what? No.
You would not like to have a target that is not going to change so much, right? And so they're thinking of sugars, right? That many viruses have glycoproteins that are, they're glycoproteins that have sugars attached to them. And could we target the sugars, right? And in this paper, they're looking at what are called N-linked glycans. These are sugars that are linked to an asparagine residue in the protein, right? And there's a 5-sugar core that they call a pentasaccharide that they say should be targetable. The 5 sugar residues right next to the asparagine. This should be targetable by small molecules.
But this gets back to the challenge I mentioned, which is we also put this same sugar moiety on our own proteins, on a lot of them.
I was going to say so many immune cells, ultra-glycosylated, and cell-to-cell communication, so many things. This paper is really cool, but I want to talk about some of the potential biological implications of using these.
Absolutely. So anyway, that's what they're going to explore here. And they're going to look at viruses with high pandemic potential. Of course, coronaviruses, filoviridae, and paramyxoviruses. So filoviridae, the Ebola viruses, right? And then the paramyxoviruses include Nipah and Hendra virus, which make people very sick.
Yeah, so a key breakthrough here is that some people have recently found ways to target just viral glycans, these synthetic carbohydrate receptors, that are apparently specific enough to hit the virus and not the rest of your immune system.
So I went back and looked at the paper where they first described this, and there's just small molecules that have structures here in this paper, which basically have been selected to bind these carbohydrate moieties in the viral glycoproteins, right? They're not antibodies. They're small chemicals that will bind these sugar molecules. And, in the previous paper, they showed that they interfered with virus replication.
These are crazy structures.
These are dihydroxy chicken wire.
Well, but they're pretty cool. I was just about to say, if you look at the center of them, there's 2 rings, and then there's 4 things that come off of them because they're called tetrapods.
Yes.
So they have 4 feet.
I wonder how they ever came up with these. I
think they did some computer-aided design, right? They present with a carbohydrate structure, and they design something that's going to bind to this, and then iterative
Amazing.
changes, right?
Because
Yeah,
sometimes,
it's very cool.
well, I guess molecules don't necessarily make sense looking at them. But these somehow, to me, make less sense. But I like them because they're
Yes.
symmetric. I like the symmetry.
I have one word for you, Rich.
What's that?
Chemistry.
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 Not plastics, because plastics came from chemistry,
Yes.
right?
Boy, was
The
that
plastic-
prescient. I think about that all the time because plastics, well, that's another
You should-
podcast,
It
Yes.
put you through college, right, Rich?
I suppose. Yeah. Yeah. Good point.
So that previously people have found these molecules, right? The SCRs, synthetic carbohydrate receptors to bind SARS-CoV-2 and HIV and Zika virus. And so they are going to expand this now with viruses that I already mentioned and try and basically make an SCR that is going to neutralize a broad range of viruses. So it's going to be used in case of a coronavirus or paramyxovirus or a filovirus outbreak. I'm just wondering, where are the influenza viruses here, right? Is that going to be another paper?
It would have to be, yes.
But you would think that that's
It's weird.
the drug
they
you
wouldn't
have.
add it.
Maybe it didn't work.
Maybe it didn't work.
Probably.
Yeah, I
I was
actually
thinking
assumed
that.
it didn't work because they're talking about pandemic viruses. I can think of a pandemic virus that's not in this list.
And
'Cause
that's
that-
definitely
you would
available.
Yeah.
You would definitely want that anyway. So they have a library of 57 SCRs, and they were screened against pseudovirus particles. So VSV they used, was it VSV or
I didn't know what the platform was. I
lentivirus?
didn't look it up.
But and
Yeah, I
either
think
VSV
they
or
are
lentivirus. VSV with the glycoprotein from SARS-CoV-2, Nipah, Hendra, et cetera, filoviruses. And so they screen this library to prevent infection, right? So these have glycoproteins from SARS-CoV-1, SARS-CoV-2, MERS coronavirus, Nipah virus, Hendra virus, Ebola virus. And they assay infectivity. They actually assay bioluminescence. And they go through all these compounds. The cells seem to be okay. They don't die, but that's a very crude assessment of cytotoxicity. And they have results with a bunch of these different compounds. Some of them decrease infection rates by over 50% for at least 5 of the viruses. Some of them hit 2 viruses. Some of them hit just 1. And one, number 13, with figures, number 13 doesn't inhibit anything. Doesn't that make sense? That I'm just kidding. Number 13. And so they use that as their control in the upcoming experiments, although, as you will see, it is not without some kind of activity. All right, then they do plaque reduction assays with SARS-CoV-2, and they use immunofluorescence-based neutralization assays with other viruses. And this SCR5 did very well against all the viruses. It inhibits 50% inhibition at ranges from 16 to 80 micromolar. And SCR7, 007, 007.
Antiviral agent 007. Yep.
I like that.
Was the best of the bunch.
IC50 between 10 and 40 micromolar. That's good. It's not bad, right? Micromolar is not bad.
By the way, confirming VSV is the platform.
Thank you very
for
much.
Pseudotyping.
But of course, that's one thing. But, bioavailability and pharmacokinetics and all that all has to be done.
Yeah.
But that's later. And tox, as Angela is going to tell us. And SCR13 didn't inhibit plaque formation with any of these viruses. They did some cytotoxicity assays in Vero cells to figure the 20% and the 50% cytotoxic concentration values. In other words, what concentration of the compound will cause half of the cells to develop cytotoxic effects. And they come up with some values. They are in the high micromolars, 100 plus micromolar will give you cytotoxicity. So it's a little close to the therapeutic dose. I'm a little worried about that. But SCR-007, the selectivity index, the ratio of the cytotoxic dose to the inhibitory dose is 5.5 to 16. So 5 to 16 fold higher than your effective dose is going to give you cytotoxicity. So you got to be careful. You have to be careful about dosing. They also tried this, one of these against 5 and 7, 005 and 007, against a non-envelope virus, rotavirus, which does have sugars on its structural proteins, and it inhibits that as well. So that's very interesting also.
At that point, we're at supplemental figure 92
Yes.
of this paper, which has a total of 134 supplemental figures.
I was
and a
hoping
total
somebody else would comment.
of 30 supplemental tables.
Yes.
There's 5 main figures, and I don't even remember if there's any main paper tables, but
Maybe one of the
Oh my
co-third
goodness.
authors was putting together all of the tables.
It's amazing. It's a lot of data, right?
That's a lot of data, yeah.
Oh my gosh.
Yeah.
I mean, there's also a lot of non-virology that we're going to get into in here. I think that's what a lot of the authors are coming from also, right? All right, so this is in cell culture. What about mice? In vivo tolerability. So you give mice intraperitoneally these compounds at 10 or 100 milligrams per kilogram. How much does a mice weigh? 100 grams or 200 grams?
No, like
22.
20 grams.
20
yeah,
grams.
like 20. The obese mice are maybe 40, but the regular mice are like 20.
So, they're not getting a lot of compound milligrams, though, but that's far in excess of the micromolar concentration. And then they look at these mice and also do some intranasal administration. And they look at they give them daily health assessments and weight measurements. Neither IP or IN administration of 10 mg per kg resulted in weight loss or adverse health. If you give them 100 mg per kg, milligrams per kilogram, you get a transient 10% reduction in body weight, which comes back by day 7.
By
So
the way,
obviously
there-
these are doing something.
Yeah, they are.
If there's a 10% reduction in body weight, that is quite
Yeah.
significant. I mean,
a lot.
endpoint is like 20%, so
Yeah. No, it's a lot. 10% of my weight is a lot of pounds.
Yeah.
definitely.
So you may have already mentioned this, but they are giving a drug at the same time as they are giving the virus. Okay.
Oh, this is right. So you're just on the toxicity test.
I'm just
We're
on
just
the
on the
toxicity.
Oh,
Yeah.
you're on the toxicity.
This is no
Yeah,
virus
sorry.
yet. This is
I think we're all going to
only
have
the drug.
opinions about the viral test.
No,
But I think
the
it's
tox
important.
is important, right?
Yeah.
Yeah, tox
to-
is important.
Because this is only one kind of tox that would be done in preclinical, right?
Yeah.
So that's body weight. And then they look at whether it messes up the liver. So they measure a liver enzyme, alanine aminotransferase, which is not supposed to be in blood normally. If you have liver damage, it is at different days. And there's no increase at 10 or 100 when you give it IP. But they found it. They did find in a couple of mice an increase in ALT, which they say is not biologically significant. But you're damaging the liver.
Yeah,
It's
I was
got to
going to
be.
say this.
It's clinically
didn't it-
significant, right?
Wasn't it 20%? I remember. I don't know if.
Yeah,
Am I
20%
up?
increase in ALT.
Which is not insignificant either.
Yeah.
That's quite significant. And the body weight for me is the most surprising thing. That something is definitely happening in these mice. That they're obviously off-target effects. That just the drug by itself.
Yeah.
At the 100 mg dose.
Exactly. Yeah. Which is obviously excessive, but
Yeah.
either way.
Yeah. So they're proving that. It's important to prove that there is, in fact, a toxic dose. It's not doing
True,
nothing.
yeah.
And then that gives them a zone, a range. They could say it's definitely not toxic here. It's definitely toxic here.
Mm-hmm.
So for treatment, which they're about to do, they could aim somewhere in between.
The little mice lived, though.
Yeah.
Although maybe they felt really bad.
Probably
Yeah,
if they're
and-
losing 10% of their body weight and got 20%
Yeah.
increase in liver enzymes. Yeah.
They were
can't.
probably not feeling well enough to go to the opera.
I was just
You know,
going to say, if you ask them, do you want to go? They'd say,
I
nah.
don't feel like it. Yeah. But this is the thing when you do safety studies in humans, they tell you, I feel this and that and the other, and you can't do that with mice. All right. So then what about protection in a mouse model? Prophylactic, right? We're going to see if we can prevent infection. So they took two, 005 and 007, and their control, which is 13, against SARS-CoV-2 in a mouse model. And they do an intranasal infection, 8 to 10 mice, and they get an intranasal dose of 5 or 7 or 13. So it's like 3 milligrams per kilogram. So it's below the dose that had some effects.
And this mouse model is genetically engineered for the receptor, and it is a highly lethal infection with SARS-CoV-2 in these mice.
Yeah, and it goes in the brain as well.
And it goes.
Which is
It's not
It's
like
not-
the human.
It's not biologically really. People doing like human ACE2 mouse models. People have more switched now to the the Ralph Barrick's SARS-CoV-2 mouse strain, like
where
the virus
has
itself.
changed.
Exactly. So
instead
you
of
can
the
use
mouse
B6 mice because it's more representative of like human infection. The ACE2 mice it's not like representative.
In the abstract, it caught my eye that they talked about SARS-CoV-2 infection in a severe animal model
Yeah.
when they really meant a severe infection in a SARS-CoV-2 model.
Yes.
Yes.
It's not a severe animal.
No. Severe animal. Poor guy.
So they give these animals the drug, and then they challenge them intranasally with 2,000 plaque-forming units of SARS-CoV-2, and then they check them, right? They monitor weight loss, clinical signs, and survival up to 14 days. At 6 days, they didn't see any death yet. There's the 16% weight loss for the saline control, 10% for SCR 13 and 5. 13 is the control. So 13 and 5 are pretty much the same, but 2% for SCR 7. And then it got better at day 9. They euthanize the 13 treated mice. This is the compound that doesn't work very well in vitro. And nobody survives to the endpoint in that group. SCR 007 treated, 90% survive, and 30% of the 005 treated mice survive. So you're getting 10% mortality with that 007 compound, right? So it's not perfect. It's only 2,000 PFU-IN. I don't think that's a lot.
But this mouse is exquisitely sensitive to the
Yeah,
virus.
with the
Yeah.
I mean,
the
and
T18.
the saline controls are all dead, and the SCR13 controls are all dead.
Yeah.
So
That's fine.
the
I'm
fact
just
that you get
being picky.
90% survival in the 007 group is really pretty impressive.
Yeah. So then they look in the brain, because in the lung and the brain, right? We know it's in the lung, the virus is in the lung, but also in the brain. This model, you get brain replication. Reduces lung and brain viral RNA by several orders of magnitudes. And again, 007 seems to be the best. SCR, James SCR. Bond, double bond. How's that?
Yes.
We
Yeah, it
already
has
used
some of
that,
those.
didn't we?
That's good.
We already used that title. It's the pathology of lung tissues, mild pathological alterations in most of the infected mice. Okay? Across all the treatment groups. Get, inflammation of various types, cells coming in and so forth. The lungs of mice that got 005 had more histopathological manifestations, more cells coming in, more hyperplasia, right? And then they say there was a 37 and 89% decrease in the average perivascular infiltrates around the blood vessels, and necrotic neurons in SCR 005 and 007 treatments compared to saline.
Which is pretty troubling, I would say. So obviously there's SCR5 is doing other things, and there's differences between SCR5. The toxicity varies quite significantly between like 007, where we didn't see that.
It also varies from the lung and the brain too,
Mm-hmm.
apparently, right? So,
But even in the control, so they didn't, this is in the supplemental figure, but they looked at like cytokine infiltration, and they looked at different cytokines in the control versus 5 and 7. And they saw that even in 13, there was increases in IL-6 and TNF-alpha and interferon gamma.
Yeah.
So there's still, it's not that nothing's going on. There's still things going on. There's still inflammation in all of the conditions, actually.
Next, they took a single time point, 5 days post-infection, and they compared the effect of these SCRs on virus titers in the lung and brain pathology and the inflammatory responses. Okay, 5 days, everybody is compared. And you have 8 to 10 mice in each group. So 5 days, there's nobody dying yet. The control mice, the 13 and 5 treated mice, all have about 9% weight loss. The 007 treated mice, 2% weight loss. It's a little better, doing a little better. Then they look at viral titers using plaque assays, RT-PCR, and immunohistochemistry. The titers decreased by 1 and 1.5 orders of magnitude for the 005 and the 007 treatments. 37% of the mice treated with 005 and 70% of those treated with 007 have no virus in the brain at 5 days post-infection. I don't know what that means.
That's pretty cool. It's a
it's
nice
great,
fun.
but
I guess there's not more, they're controlling viral replication in the brain.
Yeah, the lung is what I care about in this model.
Yeah.
Right?
Actually, in this model, what kills the mice is normally neuroinflammation. So in this model,
right.
it is actually significant, but it's not comparable to human SARS-CoV-2, which normally a week later, you're not dying from neuroinflammation.
Right. And the immunohistochemical findings were the same as the plaque assay data. Because they're looking there for staining at viral positive cells. And you can see a decrease in 005 and 007 compared to 13. They also do pathological scoring of these tissues. The lung, they're comparable between 007 and 013. So that's interesting. The scoring of lung and brain tissues at day 5, the results are comparable between 007 and SCR13 treated, right? So even though SCR13 is not inhibiting virus reproduction, it has an effect on pathology. In the brain, no pathology in mice treated with 007. So both 5 and 7 reduce morbidity, mortality, and virus loads, but 7 did it while also reducing lung histopathology in this model. They next looked at cytokine differences. This is the last biological or something done in cells or mice experiment. They measured pro-inflammatory cytokines in the bronchoalveolar lavage fluid. And they're looking at various cytokines that are indicators of inflammation. TNF-alpha, IL-6 were lower in the 007 and 13 treated groups. Okay, so 13, which doesn't inhibit virus multiplication, is inhibiting the production of pro-inflammatory cytokines. Also, IL-18 and interferon gamma were lowered 80 and 90% as well. So these compounds are interesting. They reduce viral replication, but also reduce inflammation. But and with 13, it reduces inflammation, but not virus level. So that's not enough to decrease the disease, clearly.
Yeah.
So the rest of the paper is devoted to understanding how these compounds work. So they say it could be that the binding of these SCRs to carbohydrates is preventing binding of the virus because the glycoprotein is involved in binding to the cell receptor, or it could interfere with fusion. So they do assays to measure that, and they find that for SARS-CoV-2 and 1, if they add 007 before binding It reduces infection by 80%, but not for SCR. It doesn't inhibit infection if you add it after binding. So if you bind the virus and add the drug, it doesn't inhibit. So they say this must be involved in preventing binding. But for Nipah virus, the glycoprotein, the compound appears to not interfere with binding, but interfere with fusion. So a little mechanism there. They do some NMR spectroscopy, looking at structures to show that 007 is binding to the receptor binding domain of the SARS-CoV-2 spike protein. And so they see that very clearly in these reconstructions. So the receptor binding domain, of course, is what binds the receptor ACE2, and it's glycosylated. And so these SCRs are binding the sugar moieties on the receptor binding domain. They also they make simulations to look at the binding between these compounds and the spike glycoproteins. They can see where it inserts itself in the glycan, and they model the binding of the different compounds to the isolated receptor binding domain fragment. And the interesting observation from this is that even 13 remains associated with the glycoprotein in these simulations. It doesn't leave. Even though 13 didn't have any antiviral effect,
Right.
it still is stuck on the glycoprotein. All right, here comes incellulo.
Incellular.
No, we
Yes.
passed it earlier, but yeah.
Yeah.
To understand whether N-glycan binding correlated with the incellulo inhibition trends observed for other viruses.
So can I do my little rant now?
Yeah.
Yeah,
I want
please.
to hear Kathy's
We're
rant.
setting you up,
Okay.
yeah.
Okay, so in the abstract, they talk about incellulo, and it comes up a couple other places that we've already skipped over. In fact, I just heard Vincent a couple minutes ago say something about in cells. That's all you have to do is say in cells. So this comes about because we talk about in vivo and in vitro, and there's a kind of place in between where something can, depending on who you're talking to or what they're talking about, in vitro can mean something different to different people. So in vitro can mean a cell-free extract, biochemistry, mix stuff in a test tube and see what happens. Or in vitro can mean just in cells, in cell culture, as opposed to in vivo being in animals. So you'll see people mention in animo, and then
In animo? That's terrible.
Oh, you've never seen that?
I've never
I
seen
have not
that.
seen that either.
Oh yeah,
In
Some
vivo?
people-
What? In what world? In cellulose? So,
Well,
I'm sorry.
so see, some people can refer
At
to
least it's not in anime.
right. You could refer to in vivo as being. Some people could even refer to a virus infection in cells as being in vivo, as opposed to
Right.
being
Nah.
in vitro if you're talking about the cell-free extract kind of biochemistry. So it all needs sort of definition or clarity when you're first talking about it. To introduce this new term in cellulo grates for several reasons. One is that it's like you just heard Angelo go nuts about, or not go nuts, but react about in animo. It's the same kind of thing as saying in cellulo.
oh, it's
and-
terrible. Just say in vitro cell culture
Just
Or
say
in cells.
or
just
in
say-
cells.
say
It's
what
true.
mean,
If you want to say
cells.
in
Every
cells.
every time they say in cellulo here, they could have said in cells or in cultured cells. But then I was the one who then looked up to see something about where did this in cellulo ever come about. And there's a whole pedantry thing that I found in a Protocols Online post where somebody goes nuts about it because they say it should be in cellula instead of in cellulo. It
I
all
was
has-
wondering when the Latin scholars would come in.
It has
my
to do
gosh.
with Latin and
Yep.
all kinds of other stuff. So we have digressed probably enough, but all we need to do is say in cells. In
Yes.
Do you think they added something like that just to rile people up?
No.
No, there's a,
They
there's
just
a
wanted
number,
this to be on TWiV.
There's a number
TWiV
of
and,
things
like-
in this paper that caught my eye, that there were so many of them that I'm sure they didn't do them just to get a row.
So I have a question. How do we feel about in silico?
And silico is good because it's like, that makes sense. It's like in the computer, in something that's non-biological, or there's no,
But
that's how
I remember a similar kind of reaction when it first came about too.
Oh,
Yeah.
really?
Yeah.
It's not Latin, right? I mean,
It's a
Latin
simulation.
didn't come from a place of computer chips, I don't think.
And
Yeah.
to be clear, in vitro is in glass, and glass is made of silicon.
Okay, but that's really
Well, so
It's
that's
true.
in silico too.
Okay, but we all accept in vitro as being
As
in
being,
any sort of dish.
You know,
And
I think in silico is okay. I don't
Mhm.
mind, but I think you need to explain it if you're talking to a broad audience. 'Cause
Yes.
Not everybody's going to know what it is.
I've
It's true,
certainly
yeah.
run into this problem of the sort of uncertainty around in vitro. Okay, because I always
Yes.
used to call cell culture in vitro, and the biochemists would say, "No, wait a minute, that's not in vitro; it's in cells," which in my mind is in vivo because cells are alive. Okay,
Yeah, sure,
Well.
sure.
it's true. When I
Right.
talk to my family or friends and I say in vitro, for some reason they think that it's in a person. And I think it's because like in vitro fertilization, which most people
Yes.
think of IVF, it's like in a human, in a uterus. So everybody always thinks I'm referring to in a woman or in a
Right.
human. And I'm like, no, it's in a dish. So I always just say like in my lab in a dish or like in cells from a mouse or whatever.
In vitro in a shot glass.
in a test tube.
Okay.
Exactly. Test tube. Yeah. Petri dish. They like that.
Yeah, that's good.
They wanted to know whether the binding of these SCRs correlate with inhibition that they see in cells in culture. By the way, in our textbook, we're not allowed to use cultured cells. We have to say cells in culture.
Mm.
is that
Why?
Jane doing that to you?
Anna?
Is that a
yes.
Jane?
Calling people out.
Hesitant to name.
Yes, say Jane is the arbiter of the grammar. But she says, well, cells are not cultured, so
You can't take your cells to the opera.
cells in culture. But sometimes they slip through. Anyway, cells in culture. And basically
Classical
they
music.
find a gradient of binding, and that correlates with inhibition of virus infection in cells in culture. And finally, they do a microarray to make sure that these N-glycans, which is the N-linked carbohydrates, N linked to the asparagine in the protein, are actually the targets. So in a microarray, you array many different sugars on a slide, and then you can test binding of your fluorescent SCRs, and you can see what they're binding to because the array is is a matrix where you know where everything is. So in fact, the bottom line of all that, which goes on for a long time, almost a page, they show yes, in fact, the SCRs bind to N-glycans on the viral envelope, and they either block attachment or fusion. So that's the story here. We have these they call it a proof of concept, right?
Yeah.
You could make N-glycans that are broadly inhibitory, and 007 is a really good one here. And they know the mechanism of action. They say this gets around this is what I want to talk about a little bit, the rapid mutation rate that in genomes that lead to changed proteins. But you can imagine that you could lose the N-linked glycosylation site, right? The asparagine just has to change as long as it doesn't impact the function of the glycoprotein, then now it
that's
would
the
be
thing.
resistant.
The
Right?
function of a glycoprotein is often all about the sugar.
Yeah, my
Yeah.
guess is there's going to be a huge fitness cost to that.
Yeah, in many cases, the glycoprotein seems like the whole structure is just there to hold the sugar
Yeah.
in place. And so getting rid of that sugar I don't think that's going to be trivial for the virus.
No, it isn't, but I think it has to be tested, right?
It definitely has to be tested. And I would expect resistance to these to show up. And if you haven't found resistance, then you haven't found the right conditions. Then you need to keep at it.
They should passage the virus in the presence
Yes.
of these but they also should remove the end-link glycosylation
See
site
what that does.
and see what that does. And if it makes a virus that can reproduce, then you can show, all right, it's no longer susceptible to these compounds. So,
Or if you can modify the site to get it glycosylated differently.
yeah.
So it's still a sugar, but it's a different sugar, something like
Mhm.
that. So that needs to be done. And, 007, as good as it is in these experiments, that's not the final drug. There's a
No,
lot
it's
of
not.
optimization, and a lot of what they're doing here with the binding assays and with the structure stuff is getting a real handle on mechanisms so that they can do that optimization.
Yeah, and
Yeah, 'cause-
remember the influenza H3N2 vaccine, the glycosylation changes when you grow it in eggs, and that affects antigenicity, right? So it
Yeah.
can change.
Yes.
Right?
So I want to do
Yeah,
a
so it
little,
would be very-
a
Go
little
ahead,
fact
Rich.
check here. The glycosylations are all cell mediated, right? The cells do that.
Yeah,
Yes.
that's right.
Are there really differences that are in glycosylation that are virus specific? Because the cells are doing it. Now, that doesn't mean that the virus couldn't, modulate that in some fashion. But my assumption is that by and large, those glycosylations on the virus are indistinguishable from the same things on the cells. Is that
And
right?
yet, some of these compounds like 007 can apparently distinguish, at least to the extent that you're not getting massive toxicity to the animal.
There's no distinguish between viruses as well, right?
Right,
Yeah.
and between virus and cell. And so they probably, the way the glycosylation, the way the sugar is being presented on the protein, that
Could differ,
context
yeah.
is maybe what's giving you enough of a difference here. Because
Yeah,
as we
'cause the
said at the top,
sequence-
this is a structure that does occur in cells.
So this
Mhm.
pentasaccharide, right? These 5 residues, which they list, right? Mannose, N-acetylglucosamine, N-acetylglucosamine. So that's probably also present in cellular protein.
Yeah.
Right.
That,
And
yeah.
that's
Definitely.
probably explains the toxicity that they
Yes.
see,
Mhm.
right?
Yeah.
Well, which
So,
is why
yes,
they
I'm
need
sure
to do pharmacokinetics and pharmacodynamics,
Yeah,
and
you're
also
of
how
course.
long are these hanging out? What's toxic? Like actually look at the cells, look at the immune profiling, and see like if any are affected, which are
maybe
affected.
you can, I don't know how you would make it more selective, right? Because it's the same carbohydrate sequence. What can you do? That's
Well,
what
it could be simply that I don't know how to say this. The virus is somehow more sensitive
Yes.
to these than the in places in the cell.
Yeah, it may be. It may also be a matter of distribution. Maybe these don't
Yeah.
get to places in the host where they are
Yeah.
exceedingly toxic. I don't know.
My guess is we'll find all this out
Yes.
because this is conceptually this is really interesting,
Yeah.
Yeah,
and there's some
Mhm.
tantalizing data.
it is. And it's also
Mhm.
interesting that not only are they antiviral, but they seem to be anti-inflammatory, right? So that's pretty
Hmm.
interesting because that's a component of the pathology of many virus infections. So I guess we'll hear more.
So I wanted to comment on a couple things. One is that this concept of broad spectrum antivirals, in this case, it's going to be limited to something that can inhibit something that has one of these modifications. So
Right.
a membrane virus or something like rotavirus. If you take a look at Trudy Ray's virology blog that came out yesterday, she reviews a paper that looks at a broad spectrum antiviral approach that's more immunological and then therefore wouldn't be limited to just envelope viruses. So I think it's interesting. I haven't read the primary research article, but I did read the blog post that Trudy wrote, and I think it's worth taking a look at. So it is something that people are thinking about with very different approaches, and that's kind of interesting. And the other thing is that I was muted in part when you were talking about the co-third authors, and I wasn't sure that you ever got to the senior authors of the paper.
Yes.
But you did say them.
There are
Yeah, we
two.
got it.
There are two senior authors, two
Okay.
corresponding authors.
Right. Adam Braunschweig and Hector
Yeah.
Aguilar. Okay.
Hector was just president of ASV, right?
Mm-hmm.
Past president. All right, let's do a couple of emails. Kathy, can you start off?
Lori writes, "Hello, Twivers. I really enjoyed your interview with Stanley Plotkin. His career is truly remarkable. When he made the comment, the decline of the American empire, it reminded me of thinking the exact same thing after the 2016 election results. I'm trying to be more optimistic, but sometimes it is difficult." I have to insert here that I thought about the phrase "the decline of the American empire" sometime in the early 2000s. So,
Yeah.
anyway, Lori continues, "In the early 80s in Canada, I was going to school studying animal science and took part in a clinical trial for rabies vaccination. Participants were to receive 3 doses of the vaccine. I, however, only received 2. I thought it was because the blood work after my second dose indicated I either did not require or was no longer eligible for a 3rd shot. Is it correct to assume I had a high antibody titer and so no need, or the fact that I developed hives a day or 2 after my second shot meant they were concerned about allergic reaction? I've only had hives twice in my life, and the first time was around 6 to 8 years old. No recollection of it was after a vaccination, but I am presently up to date on my jabs, and I've never had an issue with any other vaccines." So I think we could stop and pause there and say that, yeah, when you developed the hives, they didn't want you in this trial.
Yeah, they aren't gonna. If it's a double-blind trial, they aren't even gonna know, which arm you're in, and they aren't gonna break the protocol, because they think you're winning. Okay, they will break the protocol if they think you're losing for other reasons.
Anyway, Lori goes on, "I wonder if this clinical trial was the same vaccine trial Dr. Plotkin worked on, but for Canadian licensing purposes. I must say I enjoyed Dr. Plotkin's episode. I really enjoy all the TWiV episodes, but I decided to write because of the rabies story. Thanks for all you do, Lori."
Cool.
That's nice.
Yep, cool.
Angela.
Yes, Conrad writes, "Dear Microbe TV, I always enjoy the TWiV podcast, but I especially enjoyed your interview of Stanley Plotkin. I had not heard of Stanley before, and I was especially surprised when he talked about the research he was doing in 1962 when I was 8 years old. He did amazing work, and I hope to stay as sharp as him when I get older. I enjoy your podcast when you review papers. It reminds me of Journal Club in graduate school, my postdoc, and my professional career in industry. I ran the Journal Club for about 5 years for our local research group, which meant I was the presenter about 50% of the time because it was difficult to recruit busy people to prepare a presentation. I'm retired now, but I miss working in science. Again, thanks, Conrad." We don't have a choice. We're told to do Journal Club. There's no volunteering in my lab, so
It's good. We are happy to be Conrad's Journal Club and everyone
Yes.
else. This is
Definitely.
basically a journal club,
Yes.
I think.
Yeah,
it's true.
Yeah. I forget how old is Stanley. Was it 91?
3.
Yeah, 94.
94?
Wow.
Because I had the same
Wow.
reaction, man. If I could be cooking like he is at 94, that would
I'll
be
take
great,
that.
man.
Yeah.
Yeah.
Oh, yes. Fabulous. Really fabulous.
Yeah, and I wish we had time to do more oral interviews with him because he kept alluding to other stories
I
he
know.
could
Yes.
tell that would be
Yeah.
fascinating to
Yeah.
know.
I agree.
94 years, you got a lot of stories.
Mm-hmm.
Alan.
Lisa writes, "Dear Twisters, I consume and enjoy all the Microbe TV content. Thank you. I am currently enjoying the Stanley Plotkin interview. My father also was a private pilot and had tail-dragger planes and a landing strip here on our farm. He also quit flying when it was the responsible action to take. I am sharing a link to a beautiful song by Bill Callahan that I heard years ago on Philadelphia's World Cafe radio show that conveys the spirit of flight. The title of the song is Small Plane." And Lisa's in Sperryville, Virginia. And says, "Most humid, tick-infested summer ever. Good time for y'all to come to cover some arboviruses."
So, Alan, you probably heard that Plotkin learned how to fly, right?
I did, yes. I enjoyed that.
And he stopped when he said, "I don't think I
Stop
can do
it,
this."
yeah. I stopped for different reasons. It was more about realizing that I wasn't going to do anything with it professionally, and given that it was a hobby for me, I can actually tell you the moment that it really kind of I had been thinking, this is a lot of burning gasoline for just fun, and then one day I went up for one of my just practice flights just to keep sharp, And it was, I guess it was 2023, the summer. It was the first, that was the first year we had the really bad Canadian wildfire smoke coming in. And I was up there doing maneuvers and I couldn't see in the distance. I mean, it wasn't IFR conditions, but it was just like the mountains that I normally used as landmarks that are 50 miles away. Couldn't see them through the haze. And I thought, the world is literally on fire. And I'm up here burning 8 gallons an hour of avgas. I don't think I can keep doing this just for fun.
Were you IFR rated?
Oh, yeah. Yeah, I was instrument rated and I kept instrument current. Cool. But yeah, it is a tremendously fun activity and very rewarding. But if you're not going to do it professionally, I would say don't.
Well, I took a bunch of flying lessons when I was a college student in Ithaca, and I got to solo, right?
Yeah.
And then she got out of the plane, I soloed, and then I had to practice stalls. And I really hated it.
That sounds terrifying.
You pull back until you lose lift, and then you go nose first.
Terrifying.
And she said, you stall and pull back. I want you to pull back and go into a nose spin and keep spinning and then recover. And I just hate, because if you let go of what do you call the thing you're holding? The yoke. It will right itself.
Yes.
But if you pull back, you will keep in the stall. And she demonstrated that once for me.
So she wanted you to do an actual spin.
A spin. She wanted me to do a spin. Oh my God, it just scared. And I said, that's it. I'm not doing this anymore.
Yeah, your first spin is a real wake-up call. That's it.
Oh my God. But, it was Ithaca, and there are all these farms with different colored patches, and they're just spinning around. And I think it's even making that noise that you hear in the movies, Yep. Oh my God. Anyway, Rich, can you take the next one?
Felicia writes, Dear TWiV team, thanks so much for all you do. I thought you might be interested in this effort by the Society for Medical Anthropology. Amid cuts to funding for global health, assaults on scientific knowledge, and erasures of trans lives, medical anthropologists are writing op-eds and letters to the editor, to newspapers, online magazines, and websites, and creating other media for various publics. You can see a compilation of them at this site, and she gives a link, which I haven't looked at, but I will now. It says this is in the Society for Medical Anthropology journal, op-eds and letters by medical anthropologists, and there's a whole list of them here.
Cool. I mean, not cool that this is necessary, but cool that somebody's doing it, because it definitely is necessary.
Okay, so in the attempt by government officials to put us to sleep. What's the opposite of woke? These people are keeping the lights on.
Sounding the alarm.
Yeah, cool.
All right, here's one from Jennifer. Hi, beloved TWiV team. Now listen, if you start a letter like that,
you're going to get read.
I listened with interest to your great discussions of the recent Nature paper on COVID infections reactivating COVID cells, cancer cells, on both TWiV 1243 and Clinical Update. As an epidemiologist, I also did a deep dive on this paper, and I see. She links to Catherine Wu article. I don't know why. This is not Catherine Wu. It's Jennifer. Anyway, I also did a deep dive, and I wanted to push back a bit on the strength of the human results based on observational data. So just to remind you, in that paper, they looked at, in a mouse model, the effect of SARS-CoV-2 infection on reactivating dormant breast cancer cells that had metastasized to the lung. And then they looked in human data and saw some evidence for that. In the results from the UK Biobank, I also initially interpreted them as being quite consistent with the mouse model results, mainly the finding that cancer-specific mortality was elevated in the cancer survivors who tested positive with COVID compared to those who did not. But I started getting curious about how many cancer deaths there could have been over this time frame in this very specific subsample, and took a closer look at the extended data tables. And so she puts here the extended data table 2 UK biobank sensitivity analyses. So you have all COVID mortality, all cause mortality, COVID, non-COVID, and cancer mortality broken down. If you look closely, the number of deaths from cancer mortality exceed those from non-COVID mortality, which must imply that cancer mortality also includes deaths related to COVID, either as a primary or secondary cause, though the authors didn't make this clear. I also assume that means there were not enough deaths from cancer without COVID mentioned on the death certificate to analyze them as a separate category, or we would see it in the table above. I'm sure you can see where I'm going with this. The fact that cancer survivors infected with SARS-CoV-2 were more likely to die, especially in the short run, compared to survivors not infected with SARS-CoV-2, is to be completely expected. I'd expect this would be true for anyone in a high-risk category. It's also not surprising that this would show up in non-COVID causes as well, since we know COVID increases the risk of death from CVD and other causes for many months after. Cardiovascular disease, right?
Right.
So while I originally thought that the most convincing aspect of the human results was this significant finding for cancer-specific mortality in the UK biobank, in fact, this just restates the finding that COVID increases the risk of death overall. That's a big difference from suggesting these data are consistent with a reawakening of dormant cancer cells and metastasis. As Brianne pointed out, this analysis also couldn't separate out cancer subtypes and had no information on cancer recurrence or metastasis. So even in the most generous interpretation of this analysis, it is only a very indirect test of the mechanisms outlined in the mouse models. Moving on to the Flatiron Health EHR analysis, I won't go into great detail here because I simply don't think the data were appropriate for this analysis. I understand the aim to look more specifically at breast cancer and confirmed metastasis, and the data seem excellent for measuring that outcome as far as I can tell. But since COVID infection is the primary exposure of interest, its measurement is really important too. COVID infection was identified from diagnosis codes in electronic health records provided it occurred before any cancer recurrence. COVID was ascertained through August 31st, 2023. The analysis is then based on 36,216 COVID-19 negative patients and 532 positive patients, which comes out to a COVID infection rate of 1.2%. I'm sure the TWiV team knows as well as I do that this number is completely implausible, even if cancer patients were taking more precautions. This low infection prevalence is a red flag to me that COVID infections were simply poorly captured in electronic health records, which I don't find surprising. This means that it's essentially useless as an exposure variable and can't tell us anything about the effect of COVID on any outcome. I won't even speculate on the small and marginally significant effects the authors did identify here because I just think the whole exercise is compromised by the flawed COVID measurement. Overall, I think the paper's mouse models and the careful demonstration of the plausibility of this biological mechanism were convincing, but you guys can interpret that better than me. This seems important, and I hope it stimulates more research into the role of infections in cancer recurrence. Of course, the basic takeaway that cancer survivors should be mindful of minimizing exposure to infections through vaccination and prevention makes a lot of sense no matter what. But the description of the human data in the paper and a lot of media coverage gave the strong impression of confirmatory evidence for this cancer reawakening in people, but this doesn't hold up to closer methodological scrutiny. I think this is important to emphasize when talking about this paper because I know from friends that some breast cancer survivors were really panicked by these headlines. I can only imagine how terrifying it might be to be in remission and suddenly worry that your recent flu or COVID infection might reawaken sleeping cancer cells. That stress and anxiety itself can be a risk for cancer recurrence. At the beginning of the TWiV discussion, Alan mentioned that cancer rates had gone up during COVID, but as someone closely researching mortality trends, there's very little evidence of that. The paper cited in the introduction of the Nature paper looks at both underlying causes of death and multiple causes of death and finds that most of the increase in age-specific cancer mortality was due to COVID as the underlying cause.
Okay.
Rates of cancer as the underlying cause actually decreased during the pandemic, again, inconsistent with a reawakening metastasis mechanism.
I stand corrected.
In my own research, we did not see a significant increase in cancer mortality during the pandemic, either in the U.S. or other countries. Of course, this doesn't rule out COVID-related reactivation of cancer in individual cases, but overall, there was no significant spike in cancer death. This fact suggests to me that the magnitude of any COVID cancer recurrence effect could not be large. Good news. Of course, the real takeaway is that cancer survivors are at higher risk of death from COVID itself, not through reactivation of their cancer, and should continue to take precautions for that reason. That's a really good point.
Yes.
Right? Very good point. Thanks for listening. I appreciate all of your work and your thorough breakdowns of new research so much. Jen is a professor of demography and population health at the University of Oxford. But we really,
Cool.
Jennifer, thank you so much.
Yeah, great
for
letter.
It's a
Fantastic.
great email.
Really good.
You know, you could have published it on your own.
Yes.
when you said
This,
that.
is, this is a letter to a journal type. Yeah.
Yeah,
Right.
very good.
All right. I think we'll move on to some picks of the week. I can't type and talk at the same time and scroll down. Let's see. Angela, what have you got for us?
So I thought that this was there's some cool new research in bees. So yes, bees like that make honey. So I was unaware that the food concentrate that they give bees is actually lacking in certain essential nutrients that bees need to increase their production and to increase their fertility. So this paper, let me just see. Well, I have two links. I have one from the University of Oxford as a little news article saying saving bees with superfoods, new engineered supplement found to boost colony reproduction. And then there's also a paper in Nature, and the Nature paper, the first author is Eleanor Moore, and the last corresponding author is Geraldine Wright. And the paper's engineered yeast provides rare but essential pollen sterols for honeybees. So basically, honeybees need 6 essential sterols, which are, these specialized lipids that normally come from flower pollen, like in natural environments, but that in high industrialized bee colonies, it's not actually in the food. So they've using CRISPR and basically making a yeast that could then express all of these different sterols. They produced new feed, including these sterols, that can rear up to 15 times more larvae in these cases. So like these bees now reproduce more and obviously make more honey. and this is really important because especially in the United States in the last few years, honeybee colonies have lost up to 40 to 70% annually. And these are, as we know, crucial pollinators for crop production, up to 70% of crop production in the world. So like we need bees. So now that we have more understanding as to what bees need for us to use them, because now they can reproduce more, maybe this will pick up the bee deficit and the devastating crop losses that we've seen because of bees. So I thought it was just cool. So
Very
we know
cool.
what bees need.
This is the bee's needs. Yes.
The bees needs.
This could explain colony collapse.
I think some of colony collapse is actually by certain pathogens. So some of them are, So I don't know if it's associated with that. In vet school, we learned about like Varroa and 2 or 3 other pathogens that are involved in colony collapse, but maybe this will prevent it. At least there's more bees if it collapses. I don't know
And
enough
they may
about
be
bees.
healthier if they're getting a more nutritionally balanced diet when they don't have access
Exactly.
to pollen. Yes.
Exactly. Boost their immune system, let's say.
Purina bee chow. Yes.
Yeah.
Pretty cool. I like that. Kathy, what do you have for us?
Well, I picked something that is from an obituary. So Margaret Rossiter, who discovered women of science, dies at 81. So this is in the New York Times, and I put in a link that I think everybody should be able to
Yep.
use.
It works.
And so I not only do I print out papers when I'm going to review them, I still get a hard copy paper of the New York Times. And so I'm an inveterate clipper, as my parents were and other relatives. And so I have in the past sometimes cut out an obituary and given it to someone. And one of my friends said, "Don't send me any more of these." And why are you sending me these? And I think of them as a short biography. And so that oftentimes they're about somebody that I didn't know and they're sort of an unsung hero. And that was definitely the case for Margaret Rossiter. She was a historian and wrote a trilogy, Women Scientists in America, that documented in sharp detail the ways that women were excised from the annals of science. And she coined the term the Matilda effect that I hadn't heard about. So anyway, this obituary tells you a whole lot about her history, and she wrote these 3 volumes, Struggles and Strategies to 1940, Women Scientists in America. And then the second volume is Before Affirmative Action, 1940 to 1972, and then Forging a New World since 1972. And I have to admit, to my chagrin, that I only recognize the picture of one of the 3 women on these books, and that's Barbara McClintock. But she had a lasting and transformative impact on the history of women in science. She was a National Merit Scholar and a math star at Melrose High School. It took her almost 2 decades to find a permanent academic position. And how did she get into this? When she was working on her PhD at Yale on the history of agricultural science, she asked one of her professors and said, where were the women in science? And he basically mumbled, there are none, or there were none. And so she realized that there were things to do, but that it wasn't going to be easy, that she was going to be sort of fighting an uphill battle for a while. So check her out, and if you have time, you can look at these Women Scientists in America volumes.
So I'm just looking at her wiki page, right? So she had a 1-year appointment at Cornell, and then they stretched it to 2 years, and her salary was paid by 3 different departments. Okay, and then she got a MacArthur Award, and Cornell still refused to hire her. They said, "You're not in any one department, so we can't hire you." What a lot of BS!
Yep.
And then she finally got another offer from the University of Georgia, and they finally made her a professor. But it's ridiculous. Oh my gosh. Because that's the problem. If you're not in a department, there's nobody to defend you.
Right.
Yeah.
In particular, right?
Right.
'Cause I looked it up because there was some professor in some department called Rossiter, and it wasn't her because it was way after I was there. There was some other Rossiter. I thought it might be her.
Yeah.
Still going on.
Yep.
I'm sure,
Yeah,
of course.
Though it's interesting at the University of Florida, the administrative hall in the medical school had the class photos for medical school classes over the years for 50 years or something like that. They were fascinating to look at. Among other things, first of all, before a certain time, and I can't specify a date for you, they're all men. Okay. The other thing that I remember that was striking is that when you get to the 60s, there's all hair. But then the women start to arrive. And now I think typically medical classes are even more than 50% women.
Yeah.
So there is
definitely.
progress, but we're not done.
Rich, what do you have for us?
Oh, what do I have?
Whales.
Oh, yeah. So this is about tracking whales.
Amazing.
The main link here that I have is to if you're paying any attention at all, you know that I'm passionate about the PBS NewsHour, and this is a clip from the PBS NewsHour that's a feature about tracking humpback whale migration. And the interesting thing about it is that the way people have recognized for quite a while that the way you can identify humpback whales is by the pattern on the underside of their flukes. It's almost like facial recognition. Yeah. And this particular article was about using AI to help, facial recognition, to help recognize the various whales and track them. And the guy that they interviewed has created a website called Happy Whale that I've also linked here, where you can see the tracking of the individual whales. And also it allows you to, if you're, watching whales, you can submit your photos and contribute to the tracking by submitting your photos.
Cool.
And it's got little bits about individual whales and that kind of stuff. But it's a fun story.
Cool.
And the whales are cool, man. They really get around.
They swim.
Whales are amazing. Yep. Whales and elephants are amazing.
Yeah. My favorite is giraffes, but
Giraffes too.
Giraffes are
Giraffes
cool.
are pretty cool.
Alan, what do you have for us?
So this is one of those, internet meanders that happens sometimes. So I'm picking two things. One of them, I'm a published fiction author now. I flogged this on everybody in the group already. I finally got around to actually writing and finishing a fiction story, and I submitted it a few places and it got published. So I'm linking to that in case anybody has 20 minutes to kill and wants to read it. But part of that, I realized, some of the tools that I use for my regular work, I was really looking for a better way to access a dictionary for rewrites in my text editor. And I eventually stumbled across this blog post from 2014 by James Summers, who's a writer who's had a bunch of pieces in the New Yorker. And the post is called, "You're Probably Using the Wrong Dictionary." And it's really fascinating. He talks about how dictionaries have become these dry, team-produced documents that just, define the word, minimal, short, and whatever's built into your computer is probably one of these, New American Heritage Dictionary or something that just gives you the one-line definition. And he cites an essay by John McPhee, who, if you don't know who that is, you should look him up because he's an amazing writer of nonfiction. Who talks about how on his fourth draft of anything, he goes through with the dictionary handy to kind of punch up the language. And he cites how much that helps. So Summers is writing about how, McPhee doesn't seem to be using the same dictionary I am, because my dictionary is this boring thing that doesn't give anything. So he eventually tracks down McPhee is apparently using the Webster's 1913 edition, which was written by, is derived from the original written by Webster and tended to be written by a very small group of people, carrying over a lot of the, the definitions and etymologies and these lengthy descriptions and citations of how this word is used and the nuances of it and, the fine points, the fine distinctions between similar words, which in English, it's a very complex language. and it just, I found this fascinating.
That's
I think
really
anybody who uses words a lot, and I know we have a lot of language discussions on this
But
podcast.
to punch up his language, wouldn't he use a thesaurus as he's going through? Or would
No,
he
the
just discover new
dictionary-
words?
Well, no, the dictionary turns out to be a better source in a lot of ways. To, like, you think this word is not quite right. Maybe there's, or maybe it is, and I just don't realize it. And words you thought you knew the definition of, you can look up and say, yeah, that's a fine shade of distinction I hadn't seen before. It's a little different from this adjacent word. Whereas a thesaurus is just going to list those adjacent words.
But I guess to find new words, it might be difficult.
To find
For
new words, you might want to
options,
consult a
New
thesaurus.
options.
Yes.
But that's really cool.
Yeah.
He's got a comment here. Dear God, how did I not know about this dictionary?
Yes. Yes.
Pretty good.
It's funny. He criticizes the dictionaries on your computer. So
Yes.
they're just uninteresting.
And then at the very bottom, he's got instructions on ways to install. I actually came across this while looking for dictionaries to install in one of my favorite text editors, and they linked to this. And I subsequently set things up for that.
By the way, Alan, I really like your story.
Oh, thank you.
I read it right before I went to bed, and it kept me awake for a little while.
Oh.
Trying to sort the whole thing out. How long had that been in your head?
I have various things popping around in my head all the time, and I thought probably about a year ago, I thought, I ought to try writing fiction. I haven't written any fiction since like college, and that was just, didn't put a serious effort into it. And I'd been reading various stuff about story construction for my own work, and thought, that'd be a neat way to kind of try out something new, maybe expand my horizons. And I kind of, through that story, came together as one of my ideas. I have some other ideas that I may pursue.
Well, keep going.
Thank you.
Keep sending.
My pick is an article in Morbidity and Mortality Weekly Report, because I want to emphasize that good stuff is still happening at CDC. Right, this is a publication of the CDC, and this one is very interesting. Highly pathogenic avian influenza A H5N1 virus infection in a child with no known exposure, San Francisco, California, December 2024 to January 2025. So there have been 37 cases so far of H5N1 infection of people, but none of them so far in San Francisco. So this is the first one, a school-aged child in San Francisco. So she had flu, and it was uneventful. She recovered, but they took a specimen from her and typed it as influenza A virus. They didn't go further than that. And because there's enhanced surveillance now in San Francisco, in California, they sent it to the lab and they subtyped it as influenza A H5N1, which initiated then a whole epidemiological search to try and find out where she got it from.
And this is the virus that's been in dairy cattle, and most of the cases are associated with people who work directly on dairy farms.
That's right. That's right.
The kid didn't work on a dairy farm.
Kid did not work on a dairy farm. So they go through all of the investigations, contact tracing, household contacts, school contacts, health worker contacts. They try and they talk about the illness in the index patient. They sequenced it, and they show that it's the ones that are in cows. And none of the close contacts had H5N1 infection. And the only thing which is relatively suggestive, but probably is nothing, is that the parents, 2 weeks before she got sick, they went to a live poultry market and bought a chicken and brought it home and cooked it. But they say there's no evidence that actually contributed to it. They went to the market and they did some screening, even though it was well after this illness. Because remember, this is from an enhanced thing, so it happens weeks after she was sick. They said there's no evidence that. So they say she plays on the playground in school and there are lots of birds flying over. Maybe something like that was responsible for it.
Or maybe somebody said something funny at lunch and milk came out of her nose.
Indeed. But it's an example of how you do a lot of work to try and trace where something's coming from. And it's really a lot of work, right? 84 people were identified as possible contacts, and they have to go through them and so forth. You sometimes don't know. But in this case, it's kind of interesting to want to know where this is coming from. But fortunately, she's fine, right?
Yeah, and they don't seem to be any other cases related to this. So.
No.
MMWR is really a great journal. I really enjoy it.
Yeah, the only thing I worry about is if what's being not published, right?
Absolutely.
Because with this administration, you just don't know.
Well, and I worry about their long-term future. I mean, they could just stop at any moment.
Yeah, they have in this issue, outbreak of Neisseria conjunctivitis in military trainees in Texas. I mean, this is all stuff that they don't care about, right, to censor. So I just don't trust anything coming out of CDC. I don't mean to impugn any of the workers there, but because I'm sure there are people looking at stuff before it's published and saying you can or can't publish this, right? And that's just not the way public health works, unfortunately.
And I'm sure for the career workers there, this is an absolutely horrifying episode in the history of a legendary institution that they can't talk about.
Yeah.
No, it certainly doesn't deserve to be treated this way.
No.
But anyway, MMWR is free, so it's very interesting. You can they investigate outbreaks of various diseases, and it's fun to read sometimes. We've talked about articles many times. Well, that is it. Our time is up, folks. That's TWiV 1251. You can find the show notes at microbe.tv/TWiV. You can send questions, comments, or picks of the week, TWiV at microbe.tv. And if you like these programs, we'd love to have your support. Microbe.tv/contribute. Kathy Spindler is Professor Emerita at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This was a lot of fun.
Rich Condit is an Emeritus Professor, University of Florida, Gainesville, currently in Austin, Texas. Thank you, Rich.
Sure enough, always a good time.
Angela Mingarelli is at McGill University ImmuneVet, IMMUNEVET on Blue Sky. Thank you, Angela.
Thank you. Enjoy the rest of the warm weather, everyone. Those of us that have imminent winter, enjoy.
You like winter, though, right?
It's true, but it's long. But I like the beginning of winter.
Alan Dove is at alandove.com and turbidplaque.com. Thank you, Alan.
Thank you. It's always a pleasure.
I'm Vincent Racaniello. You can find me at microbe.tv. And on Blue Sky, we are Microbe TV without the dot. microbetv.bluesky, bsky.social. I'd like to thank the American Society for Virology and the American Society for Microbiology for their support of TWiV, Ronald Jenkins for the music, and Jolene Ramsey for the timestamps. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.